Good evening, everyone. My name is Andy. Today we are going to present the midterm progress of our Mooc project. I will take you through the journey of our development so far. We have six members in Team 01, Sharon, Xiaodan, Della, Albert, Michael, and me. Here's an overview of what we will cover today. There are four parts of our report: background and objectives, tech stack and implementation, progress and achievements, and future outlook. In recent years, online education has gained remarkable traction. Platforms like Mooc have transformed traditional learning methods, offering flexibility and accessibility. Our Mooc system aims to provide personalized learning experiences, secure access control, and course management features. To achieve our vision, our team focused on 5 key objectives: implementing login and logout features, developing RBAC system for flexible and secure user management, carousel models and comment management system, and also collaborating closely with our other teams to ensure seamless integration of all modules. To deliver a high-performance platform, we chose a modern and scalable tech stack. On the front end, we are going to use React combined with Material UI, powerful component library that ensures consistency and responsiveness. On the back end, ASP.NET Core, implemented in C#, provided a security and efficient framework for API development. For the database, we leveraged Navicat for design and entity framework for seamless ORM-based operations. And we also use SourceTree for version control to streamline team collaboration. With this solid foundation, let's now explore what we've achieved so far. This is the login API, the entry point of our authentication system. Users submit their credentials, such as username and password, via a POST request to the endpoint. The request body is in JSON format and includes username and password. Here's how the API works in practice. The user sends a login request if the credentials are correct. The server responds with a 200 success status and a JWT. This token is it's the key to accessing secure areas of the platform. This diagram showcases the models designed by our team. As part of our responsibilities, we developed core features such as menu management, user roles, and so on. Let me now walk you through the menu module, a key component of our contributions. Here are the menu-related API endpoints that our team has successfully implemented. These endpoints enable key functionalities such as adding, updating, deleting, and retrieving menus. They ensure that the menu management process is both efficient and scalable. This slide shows the getBy page endpoint, which supports pagination and filtering. In this example, we send a request with page index 1 and page size 10, which retrieves the first 10 menus. Additional filtering and sorting can also be applied. The response provides a structured list of menus, including key details like title, permission, and menu type. Here is the post add menu endpoint. To add a new menu, you need to provide fields like ID, title, permission, and menu type in the request body. For example, adding a menu with ID 11, title string, and menu type 1 creates a new menu successfully. This is a delete menu endpoint, which is used to remove a menu by its ID. For example, calling delete menu with ID 11, the response confirms the success of the operation with a status 200 and is success true. This endpoint allows us to retrieve detailed information about the specific menu by providing its ID. For example, entering 19 will display the menu details, including the children attribute, which shows all its submenus. This endpoint returns the complete tree structure of all menus without requiring any input parameters. It organized menus hierarchically, making it easier to view their relationships and structure. Finally, let's take a look at our unit test results. All key functionalities, such as adding, deleting, and updating menus, have been thoroughly tested, and everything is working as expected. Now I'll hand it over to Sharon, who will walk you through the user section.
Thank you, Andy. My name is Sharon. I'm responsible for the user part of the code. These are the user backend API I've written. Similar to menu, it includes all CRUD methods. Specifically, it has both get user, just using notation, get user by page, the pagination, as well as by their username. Next slide, please. Next slide, please. As we can see, all unit tests as well as the integration tests have passed. As for the, as you can see, all the tests have passed. Andy, next slides, please. Andy. Next page. Yep. As you can see, all yes, for the role assignment in users, I've added a helper function here to validate the role IDs in both create and update endpoints before I use the user role table to assign the roles to their corresponding users. Similar logics applies to the update methods. Next slide, please. Next slide. Hello.
Yeah.
Next slides, please. Yep.
I think it's internet problem.
Yeah, so it's very similar logics. Before assigning roles, I've distinguished what roles to add and to remove, as you can see here. Before apply them according to the user role table again. That's it. I'll hand it over to Michael.
Thanks, Sharon. Good evening. I'm Michael, and I'm responsible for the role part. And the database diagram shows how the role connects with other entities. We can see here the role and menu. The role and the user have many relationships. So I have created join tables, connecting them respectively. Next slide, please. The UML diagram shows how it works. Let's suppose that we have a main user logged in here with the full power, perform create, update, read, and delete action. The main user can assign one or multiple roles to himself. Since the role is associated with multiple permission or actions, the admin user can act accordingly. Next slide, please. Here's the backend design, API design I implemented and in the 1.5 months, and I've done 5 endpoints. And for example, as for the GitHub page, and it loads all the data from database and presents them page by page in the front end. The by ID endpoint gets a particular role using its ID, and the other 3 endpoints are just normal CRUD services. Next slide, please. Apart from the API design, I also wrote unit and integration tests with 100% code coverage. I will later incorporate them in the CI pipeline to ensure code quality using GitHub Actions. Next slide, please. Here's the role component in the front end. I created using the React and the Material UI, which is very popular React and CSS library, as Andy mentioned before. The role component consumes backend APIs and can successfully fetches all the data from the backend. Next slide, please. Here's the front end. Here's the front end with all the data that loaded from the backend. We have 6 roles here. And we have 3 admins and 3 teachers. And we currently only have 2 types of role, and maybe we'll increase more in the days to come. So aside from the technical contributions, and also actively participate in solving code conflicts and helping teammates fixing bugs and review pull requests. I think that's all for me. And over to you, Annie. Thanks.
Okay, in the upcoming stages, we plan to implement the logout API, carousel and comment related APIs, and further enhance the front-end interface. Our primary focus is to accelerate the integration between the front-end and back-end system to ensure seamless functionality. Now I'll hand over the time to Team 2 and 3 to introduce the other parts of the project. Yafei.
Thanks, Andy. I'll take it over. My name is Rai. Just let me share my screen first. Can you guys see my screen?
Yes.
Yeah. Yeah, my name is Rai. So we are team number 2, and our team in charge of the course module section from Mooc system. And before we get started, let me just introduce our team members. Yafei is our team leader, and we got developers Millie, Young, Keon, and Laura. So since most of us have jobs, so we heavily rely on Confluence and Jira to manage our project. We're currently at Sprint 3. And our demo include topics like our current progress, technology stack, and our API design, database design, and the testing. And team leader will wrap up this with the future perspective. We are building a tool to simplify the work for faculty staff, helping administrator and teachers to streamline the works. This is not for students to enroll and attend the course. This is more for course design, course building, course launch is a management panel. So let me show the page we have done. We have already done our backend, and at this time we are testing and maintaining our backend. And we started front end setup, and this is on the construction, so it's more like a late areas. But we have integrated some APIs already. So on the left panels, firstly we have teacher section, because you really want to assign teacher to course and assign course to teacher when you're designing the course. But teacher is more like a user, so we put it under team 1's people management. Our main job are based on these 3 sections. We start from course sections, and you see all the courses displayed here. But in the reality, it could be thousands of courses. So we rely on category to nail down each sections to make the users too quick find their courses. We may have to we may have to apply a search bar here. So that's why we have to manage our categories. And also course launch, because courses is more like for static content management. But course launch is actually like in where the users can launch all the courses in a batch. So let's take a course, for example. Eventually those things, all the course sessions, or the media will be all editable, which means you can edit someone, you can edit, you can update, and you can delete. And this course is more like a concept with metadata, which you can reuse, integrate when you create each published version of the different courses. And if you go into this specific one, it tells you the published version, different details, and the different session panels. And you can update someone, this one, just by save them and close. This one will be reflected. And also you can manage all the learning materials here for users to learn. You can also upload. Let's do a testing. But because my net speaking is limited to the bandwidth, so I probably can't speak. Just bear with me for 30 seconds. After this uploading finish, I will explain. So you see it's uploaded successfully. If we click here, we can review the videos. We can review the videos here. Can you guys hear me now? Hello. Yeah. Thanks. Yeah. So what happened was we upload this through our backend to S3, and we chunking our video, and we use the technology offered by .NET, which is called SynchronR. And the SynchronR can send real-time data from backend to the front end. Now receive the data in the front end and present the progress bar and calculate the percentage has been done to show it to users. And yeah, that's all for front end at this moment. So for what's happening behind the scene, like API and backend technology, I will hand over to Yang.
Thank you, Ray. My name is Yang. I will talk about the RESTful API and how to build them with .NET. The diagram above shows the concept of a REST API. A RESTful API is a simple way for client and server to talk to each other online. And here are some basic ideas. First is actions. We use words like get, post, put, and delete to do things. To get information about a course, create a new session, or create or update a student's enrollment. Each request needs all the details. It's like sending a letter with the full address and everything you want to say in it. This keeps things simple and organized. Next page, please. .NET provides the perfect toolkit to build the Mooc API, bringing those RESTful principles to life. Here is how we structure it. First, we have the models for all the key parts of our Mooc application. For example, course, first is course. Course represents a type of course like React, Node.js, including the title and description. The course instance represents a specific offering of a course with states, enrollments, and all the sessions within it. And the session represents a single session within a course instance. Then there are service. They are like the organizers of our data, making sure everything is stored correctly in the database. The course service, for instance, taking care of the managing of all the information about our course in the database. Finally, we have the controllers, thinking of them as helpful guides, making sure every request gets to the right place. For example, the course controller handles all the requests about course, ensuring user gets the information they need quickly and easily. This helps make our Mooc API user-friendly and efficient. And then I will pass to Millie for the next part.
Okay, thanks, Yang. My name is Millie. As you can see, this is our ER diagram for our course model. And I'm not explaining them one by one today. I'd just like to show two challenges we faced in our data model design and how we solved them to improve flexibility and scalability. Next page, please. And the first challenge we faced is to handle many-to-many relationships. Because in our system, teachers and course instance have many-to-many relationships. A teacher can manage multiple course instances, and each course instance can involve multiple teachers. To solve this, we created a teacher course instance table as a bridge and add flexibility. For example, the permission type field can define roles, like whether a teacher can upload, edit, or delete media. This solution helps us managing the complexity of many-to-many relationships while meeting different business needs. We also focused on data integrity. Before deleting a teacher, we will check if they are assigned to any active course instance. This can prevent offender records. The second one is managing session order. Because each course instance have multiple sessions, since our Snowflake ID generation doesn't guarantee the order, sessions could appear out of screens. For example, basics might show up after the summary. To fix this, we added an order field to the session table. This ensures that sessions displays in the correct order, like basics, case studies, and summaries one by one. When a new session is added, it can automatically calculate the total number of existing sessions and count the number to add one, to ensure the new sessions is placed at the end. All of this design provide a solid foundation for efficient system operation and for future expansion. Next, I'll hand it over to Yafei to introduce the next part.
Thanks, Millie. Today I'm Yafei. Today I'm going to talk about Swagger utilization, testing strategy we use, and the future prospects. The first part is Swagger utilization. As you know, Swagger has been a vital tool for documentation and testing. In the picture, you can see each API is clearly documented with usage requirements, parameters, and responses. You can also see that a key milestone was implementing file uploads to AWS directly through Swagger, just as Ray showed us, improving efficiency and system interaction. Looking ahead, we will enhance Swagger documentation to cover all functionalities and ensure it remains a clear and reliable resource. Next, please. Yes, testing strategy and adjustment. Testing is essential to our development process. We use n-test to ensure isolation, coverage, and readability. Techniques like tear down or proper naming and reset mock can enhance test clarity and reliability. Initially, we planned to test all API comprehensively, but due to workload constraints, we prioritize critical APIs for front-end integration. This allowed the front end to proceed smoothly and kept the team motivated by delivering visible results quickly. In the future, we will complete remain tests, expand coverage, and explore more efficient test methods. The last part is future prospects. Our future goals focus on both the project and the team. Technically, we will strengthen front-end and back-end skills, increase test coverage, optimize performance, and improve our user experience as well. For the team, we'll enhance communication, refine collaboration tools, and organize some activities to boost cohesion and productivity. Through those steps, we will ensure a robust project and a motivated team ready for the future challenges. Now my part is finished. I'm going to pass it to team 3. Thank you.
Okay. Can you see it now? Okay. Good evening, everyone. Welcome to our midterm demo presentation. We are the Mooc team number 3. Today, I'll introduce the progress of our team, especially focus on the core module that we're responsible for. So this is our table of contents. And first of all, I'd like to briefly introduce our team. Our team is considered of Raymond, which is me, Jason, Devin, Gavin, Amy, and Zora. And to talk about our system, our Mooc system is divided into 2 main parts. The first of it is the front-end student system. It allows students to participate in online courses, complete exams, and obtain certificate upon the passing. And the back-end management system is provide tools for teachers to manage the questions, generate exam papers, grade exam, and handle the permissions. And the core module of our team is responsible for the exam management in the back-end system, which include the following features like managing questions and generating exam papers, automatically exam grading and a certificate granted, and efficiently publish the exams to support the simulate learning and evaluate the process. And next, I'd like to talk about the progress of our team. In terms of the development, we have achieved the following milestones. First of all, the data structure. We designed an efficient database structure tailored to the needs of the exam management, covering questions and exams. So the questions management is accommodated the various of type of questions like choice, judgment, and short answer questions. We designed the separate tables for each question type. It can enable us with the scalability and efficiency. And next, we have the exam paper management. This database design supports the flexibility of exam paper generation by associating the questions in the question with the exam table, enabling dynamic paper creations. And to talk about the backend APIs, I'd like to introduce our teammate Jason to talk about it. Jason.
Thanks, Raymond. In order to improve the function of the entire exam management, we have compiled the API of question type and 3 different questions, such as true or false, multiple choice, and short answer. And at first, for the basic question bank, we have writing corresponding API for question type and 3 different questions. These APIs are developed based on the base classes and interfaces in the project framework. As shown in the figure, for each question type, the functions of paging to obtain the question list, creating, deleting, modifying, and checking are implemented. The special queries are extended based on the framework, such as the querying through the type name in question type. Next, please. All our codes are based on the CRUD base class and interface in the framework. The functions are implemented by the inheriting and implementing the interface. The data is transmitted between the service and the controller through the DTO to avoid directly exposing the structure of the entity class. Some custom logic is added to the basic functions of CRUD through override, such as checking the sequences of type name in create async and logically verifying type name in update async to avoid updating duplicate question bank types. And finally, in the controller, all API call specific business logic through the service and achieve decoupling through dependency injection. And next, please. And we added some test data to the database so that we can test the API. And for this part and others, I will hand it over to our teammate, Devin. Devin, please.
Thank you, Jason. So now I'm going to talk about the base modules of our backend. So we mainly have 2 sides. One side is for the question. So here we have 3 question types, like the judgment question, the choice question, and the short answer question as well. So apart from these questions, the choice question has a option table as well. So on the other side is the exam. So the exam has mainly 3 modules. A is a exam question, exam, and the exam publish. So I configured the relationship between these modules, and for example, like the foreign key part in the extension file. So for example, like when exam will include multiple exam questions, and one exam questions will only have 1 exam. So after I configured these relationships, and we have the base, so we inserted some database seeds. Okay, so during inject these database seeds, we have to consider the sequence. Like we have to inject the question part first, and then we do the exam part. So otherwise it will it will result in many bugs, such as foreign key restriction, something like that. So we figured out a lot of bugs like that. So yeah, so next page, please. Yeah, sorry, next, again, next. Yeah, so here is about the web APIs and the services. So we have So this is for the exam side. So I have built this basic endpoints for the exam related modules. So one thing interesting here, one thing important here is like we need to consider the inclusion. For example, like when we fetching the exam, when we fetching the exam list, each exam will include multiple exam questions. So the exam question will be embedded into the response, into the exam response. So this part we will need to configure some relationship in the service. So here maybe we here we did a eager loading, so that the performance will be a little bit better. Next page. Yeah, so this is about the response and the payload of the Swagger. So here, for example, the choice question. So take the choice question for example. So in the payload, in the payload, when we pass the parameter, for example, like the created by user or updated by user, we need to make sure the user actually exists in the database. Otherwise, it will just give the error. Like, yeah. So other things is about the records and the response here. Okay, next page. Yeah, so let's welcome my team member Raymond to introduce.
Okay, thank you, Devin. Let's talk about the code structure. Our backend system are using the .NET framework to build a whole backend for the management system. This design ensures the system can efficiently handle the future feature expansion and changing their requirements. So first of all, the system is divided into multiple function modules, such as like question management and exam management. And we have the code maintainability by separating the logic layer, data layer, and interface layer through a clear folder structure and naming conventions. And we also have the efficient API design by using the RESTful principles with the clear semantics that facilitate front-end and back-end interactions. And last, I'd like to talk about our summary. We successfully designed a database structure tailored with the exam management needs, and we developed the CURD APIs, and we achieved the core functionalities of the exam management system. So we will continue to work hard to further refine the system, aiming to deliver the efficient online education platform. So talk about the future plan. We are going to complete the exam management APIs, develop the exam grading and automation, and designs the implementation of the backend UI. And that's our end of presentation. Thank you.